One of the things I didn't account for that I should have is I drilled these holes out to the shoulder bolt shoulder diameter. So now we have to center the holes we're putting in here. I should have put the tap drill size. These are 1/4x20 thread in there first, and then I could have drilled that out after, and it would have given me the centering position. So, I mean, they're close enough. It's a subtle difference, but I'll eyeball it, mark out the position, and then so when you do that, the drill spins out, but you can get a sense of where it started. Tap the hole and then finish that, or rather punch the hole there and do it. I also have a little gauge block in here. This distance here should start at 3/4, and then that gives us enough in terms of compressing it, and then the piston presses against here to take up the slack. I ended up taking it over to the drill press. I had to just scoot it in a little bit because of the location of our plug hole originally, so that's just something I'll have to correct in the design. It's going to be a bottomed hole. It doesn't go all the way through because of the U-channel, so I drilled down deep enough so that there's plenty of clearance for the shoulder bolt length. And then use I think I'll be able to use just a regular tap to do that. Definitely took some massaging, but if you tighten it down, bump it around a little bit, it goes on. We've got pretty good motion. There's no lubricant or anything in here, and that'll work just fine. The piston mounts to this here. I've made the mark here. It's probably difficult to see on the camera, but the crucial thing to check is with calipers that you have the necessary clearance for that. So you want it to be 2.5 inches plus up from the bottom of the U-channel. Here we've got right about 273. And I'm going to transfer this measurement onto the back there. I'll probably bump it up to 275 because of the way this lays. It'll be easier to throw it in the drill press this way. Now, I probably should have done this mounting hole before I did the upper support rail, but I'll correct that in the directions. And then, of course, the in measurement, not as crucial. And there we have 1 inch. 5, yeah, so we'll be 285 up from the bottom of the outer plate. Here's the piston that will take up the slack in the belt. Mounts there, and will press against the underside of this particular crossbar here. They have just little ball end bolts that go into the ends of the piston, just snap in. And I'm going to use some cutoff from the support bars here, just a little riser on this end, and then a little extension on this end. This just mounts with an M8 thread, pretty straightforward. So I'm going to go cut this on the bandsaw and then weld that up quickly. The top post is welded on here for the bolt for the piston, and I just put a clearance hole in there, and then this size tubing has a nice fit on a M8 nut. These bolts are fairly forgiving just because of the ball end. You have a lot of clearance. Here's the little support brace we'll use to mount the other end of the piston. I did take a moment just to dull off the edges here on the bench grinder so that it's not going to catch a finger, things like that. Of course, there's a lot of grinding that has to be done on the base as well. This will get mounted up here, and then the piston catches it. I'm going to clamp it in place and then dry fit it, and that'll help line up with the piston, and then I'll weld it. I'm a little concerned with this piston putting too much pressure on the belt. You can compress it by hand and so forth, but we'll see. I have to look up some of the specs in terms of what that pressure should be. Given the size of kind of our large platen here, it does push out quite a bit farther than I was anticipating, just conceiving the belt pressure. So anyway, now I'll go ahead and drill the platen assembly. It's a little hard to make out the marks, but spaces for the pulleys, and then spaces for where those blocks, where the pins for the platen backing will mount, and then a hole back here that matches up to a hole on the end here, which is the pivot for the platen to rotate. I'm thinking about how to do the slot. I mean, I have the CNC mill, so I can very easily do an arc slot. For folks that don't have that, potentially if you're building your own grinder, you don't have that, I want to see if I can come up with a way or some mechanism that will allow you to control that rotation and lock it in place without that trouble. So I need to think on. This is the basic layout of how the platen is going to work. There's two pieces down here that are the same. I'm going to tack those together just so that they stay in place and I can lay out and drill the holes. Each end here will get clipped, just squared off so that it doesn't interfere with the rotation of the belt on the pulleys. We have these two blocks that need to get trimmed down a little bit to 2.5 to separate one side of the platen from the other. And then we have these dowel pins and these bearings that slide very nicely. These bearings will live in here, and the dowel pin will slide to the platen or multiple different platens or sub-platen, whatever you want to call it. This is a pyroceram high temperature glass that's suitable up to extremely high temperatures. So I'm going to give that a shot, but it's going to have a backing, something that the dowel pins go into, and that's just going to be basic aluminum here that gets trimmed down to size. So there'll be that. And then I think I'm going to silicone adhesive, use a thin, a very thin running silicone adhesive to adhere that. And I may do some kind of recess or lip. Eventually these do tend to break and they shatter, and of course then you got high-speed belt and little pieces of glass running around. So if you have a lip or something, from what I've read, it can reduce the types of damage that can result from that. Just catches it. And then I will have to do some sort of set screw or something into the dowel just to hold the platen position in place, but it gives you a little bit of a leeway to do that. So first I'll start with this piece, cut that down to size, get the backing ready, mount the dowel pins into this. These are steel as aluminum. I think I'll probably just use Loctite, but I need to get a sense about perhaps this needs to be thicker, but I don't know, we'll see. I want to see how tightly I can get the holes for this and all that. So that's the basic layout. Just finished drilling these out and cutting off the end here to give us clearance. So now it's going to be the sort of first full assembly. We don't have the actual platen backing, but we should be able to even fire up the belt here if things line up well. So let's do this. Okay, get this on here. Snug it up a little bit. And we are going to need some washers to seat the pulleys totally correctly. You can see there's too much play there, but I want to get the measurement for those, and that one isn't Loctite is in there. Okay, there we go. Get those on. All right, and I still have to grease this up or oil it a little bit. It's a little frictiony. Give it a glove tap there. Okay. Hey, look at that. Our tracking's a little crazy, but that's okay. Why is that cantered? That's looking a little odd on that. Oh, it just splayed out more than it should be. There we go. Okay. All right. So far, so good. Looks like a belt grinder. We have our base platen here cut to size, and also just some general purpose layout lines. Here are two blocks that will go into the platen as spacers for those pins that control the distance this is in and out. Now, in laying this out, you have a lot of flexibility as long as this is square to this and this is within the range of the holes on the side of the platen. Other than that, and then this is loosely centered. Other than that, doesn't matter because we're going to drill the holes for it in place from the platen. I'm kind of building this in a way that assumes that you're using just basic hand tools and not some kind of CNC control type thing. So I'm just going to space these a 1/4 inch from each side, and then square them up. And I'm going to super glue these in place so that we can drill a pilot hole through both, and that will allow us to line up the bushing here and the pin so that they're both very square. There's some other ways that this could be constructed perhaps more easily, but we do need this clearance space here so that you can rotate around that arm that sticks out, the support arm. When you're doing these super glues, make sure you use a lot. That is what helps keep it secure. It's going to ooze out, it makes a mess, but it holds tightly while you're drilling and takes some wear and tear. Gives you a little bit of working time also. All right, good on that end. Good there with the kitty corner. Okay. Double check our fit. Okay, looks good. And now I'm going to put a weight on this and let it sit for a while, set up before I go and drill out the pilot hole. We have our pilot holes drilled. It's a good idea to witness mark the different items so you can line them up exactly as they were before, just to correct for any of the slight differences you might have had in measuring. That'll keep everything smooth and keep this in and out on the bearings. Now I'm going to drill out the 1-inch hole for the bushing here. And the size of the bushings and the pin don't particularly matter. These are ones I just had on hand. And then I'll also drill out the 1/2-inch size holes for the pins. Ideally, if you have a reamer, you can ream those. If you don't, try and use a slightly undersized drill bit. Just make sure that the fit of the pin in there is very snug. And then we'll want to Loctite all that together so the pins will Loctite into this bottom and then the bushings will Loctite onto these. And you want to do it with them all situated so that you get smooth motion. Here's a look at the platen assembly and how that slides in there. They're real snug right now, so I haven't so far needed a way to tighten it down, but that is necessary. I've just been trying to think about how best to mount that. They might need a long hole here with a knob or something like that, but certainly in this scenario it works so well. And I need to do a little more research about how to mount the glass to this safely. I just didn't want to mess with that yet. And frankly, as a flat plate of aluminum, it's worked pretty good for what I need to do so far. So just some. So you can see just how this whole assembly comes together, fairly straightforward. I think smaller bearings, drilling those 1-inch holes is a real pain in the butt, so smaller bearings will be a little bit easier. I'll make a couple of tweaks on the design page now it's assembled and working. Just show you the belt change here. Can reach over, pull down, slides right off. You can see that there's some kick up at the top here. That originates out of the fact that I direct drove the pulley and neither the belt grinder nor the motor itself is mounted yet. Kind of where I plan to mount it, I need to move some things and it's really not lit well for the camera. So I ended up direct driving because I had tried this bearing, which is fine, but because of its self-aligning nature, it introduces its own set of problems when the shaft is not mounted on the other side. I'm also waiting on the finish bolts here. Lengthwise, they shipped me the wrong ones. I ordered the right ones, but I got sent the wrong ones. And you can see there that the shaft on the motor is not quite long enough for this size pulley through the 1-inch plate. So that's going to wrap up this DIY knife grinder build. I am waiting for these replacement bolts here. And there's plenty of tweaks I need to mount the whole thing up, but this conveys how to build it, the different parameters involved, and I'm really happy with how it came out. I mean, rigidity-wise, this isn't even bolted down, and I can put, you know, quite a bit of force, really, really lean into it. The motor right now is running at 6 hertz, so that's 1/10 of its actual performance, and that's what I wanted, really strong torque at really low speeds, just to be able to control, because I do a lot of freehand finishing and just little touch-ups. And you can see there at the bottom the little pile of aluminum we already created. So thanks again for watching, and I'll see you next time.